This video is sponsored by ERI and LinkUp Communications. I'm in Chandler, Indiana at the factory for ERI. Now, ERI, they make antennas, feed lines, filters, towers. I mean, you've probably interacted with their stuff before or have seen their stuff before at the station you may have been at and never really thought too much about it. Well, I'm gonna get an opportunity to show you how they build these things. I am really excited about this tour. I'm meeting up with Phil Harland. He works for ERI, and he's gonna be our tour guide for today. So let's get this started because I really am excited about this tour. The ERI facility in Chandler, Indiana is divided into two campuses. The main campus is 99 acres with large buildings full of supplies, tools, and antennas in the works. The second campus, called the Test Site, is 50 acres. We'll get there in a bit. While I know this to be a factory of antennas, my host described it as...
We're just a big machine shop with a lot of electrical engineers and some vector analyzers. And of course, we also have structural engineers on staff. The other part of our business is doing big towers.
So we start our tour in the main building where the offices and the machine shop is located.
We have raw material that comes in the doors, aluminum, copper, brass, either rod or a tube. Goes through the saws, it's cut to length, and then it heads into the machine shop, and it works its way from one end of the building to the other, depending on what the metal is that we're using and what we're making. Everything from antennas to transmission line components to filters for both FM and television. And then, of course, the Rototiller. And in addition to the Rototiller, we also manufacture our high-power 1180 and 1190 master FM antennas. This cell is primarily focused on doing television antennas, mostly low-power UHF slots. I have a high-power top-mounted TV antenna in the back here that I'll be showing you as we go through the structural shop. After the components are machined, in the case of the Rototiller, the arms bent, they head into this back corner, and this is where they are actually welded up into the arms or final tanks for filters, and then they move out here. And these are racks of arms for Rototiller FM antennas, both low power and high power. These are waiting stage to go into this TIG cell where they'll be fabricated up. In the event that we need to get something out in a hurry, we have our own silver plating and anodizing operation. Oh, wow. Now, most of the high volume stuff we send out because we've got plenty of electroplaters in this area. And then, of course, we also have a small acid cleaning operation here as well. Those are some arms for some Rototillers that after they've been hard soldered up, and they're just going to be through to be dip cleaned. And then this area in the back is where the Rototillers start life. Basically, you've got 3 different arms for the low power and 5 different arms for the high power, and depending on frequency. So it's really a matter of selecting the component parts you need to build a particular FM antenna, and all of those are staged in this area. And of course, depending on volume, the number of raw pieces we have in here goes up and down depending on the product mix and what's gone through. These are some input matching sections. And of course, the interbay lines, they're cut based on order because their length changes with frequency. So they pull the arms they need, and they're picked and assembled. And then when the antenna's done here, it goes in this area where it's boxed and packaged. And then it heads over to the other building, and that's actually where it's shipped from, and we'll go through there as well. And then in addition to making FM antennas, we have the TV antennas. This is where the rigid line components are manufactured. So the rigid line sections themselves are done out in another building. We'll go by there as well. But this is where elbows, spring hangers, the fixed hangers, the gas barriers, all of those things are done. So here's a stack of 3 1/8 inch elbows. But there's a whole bunch of different piece parts to a transmission line system, and this is where they come from. Once all the parts are pulled and the bays are put together, the component parts will come out here to the deck. This is an end-fed LPX4 bay with realms. We tune these on a like structure, and everything's labeled. They are tuned with the radomes on them while they come on and off. And of course the red stripe goes down.
Yes.
We always seize the opportunity to say that again. And then we've got a pole here. And then also, on occasion, we'll put a larger tower out here if it needs to go on a 10-foot face or whatever, and it's a multi-frequency antenna, because the Rototiller, not the LPX, but the high-power Rototiller, you can also build those for multiple channels.
Oh, okay.
So if you want to diplex 2 or 3 FM stations together, we can also do that in a Rototiller.
Nice.
This is the way it leaves the factory, and then of course we have we offer an optional service where our field service people will come out and actually fine match the antenna after it's installed.
Gotcha.
So
I'm in Chandler, Indiana at ERI with my host, Bill Harland. We looked at the machine shop and assembly part of the main building, and now are moving on to the weld shop.
And so this is a weld shop, so it's not air conditioned. Fortunately, you're not here in the middle of August. And at the moment, we don't have a large tower going through the shop. So when that happens, everybody's cross-trained. So one of the benefits we got out of the repack was we expanded the facility. So we really have this set up as a zero setup operation. So everything is each cell is set up to do the work it's supposed to do, and we move the labor around wherever we need it. And this cell back here is where the brackets are done for the FM antennas and the low power UHF antennas. Those are some L brackets for a Rototiller in the back there. Just like the shop next door, only here we're doing it with steel. The raw material comes in, it's cut to length, and then it goes through the cell and is welded up. It's a top-mounted UHF television antenna for Brazil.
Oh, okay.
This is our Cascade. These two machines here are where we actually slot the antenna.
Okay.
So the pipe's laid here, and those are plasma cutters. And so they cut the slots. And the benefit is, with our design, all the slots are the same width and length, but they're spaced differently all up and down the outer conductor, and that's how we get it to tune.
Oh, okay.
So, and all that pattern development is done out in the Anechoic Chamber, which we'll also see.
Very cool.
So, they just finished welding the flange on the bottom of this one. We're like most job shops. We have a very large facility because we have so many different things we do.
Right.
And it's really about, if you're a broadcast equipment company, you have a huge catalog of stuff. Mm-hmm. You don't just, the thing is, you just don't ship very many of each one each year.
Right.
So in order to be in business, you've got to have a portfolio of different things to make sure you can meet lots of different requirements. We're a single source supplier. From the output of the transmitter, we do filters, and that's what's in here. This is the filter lab. And we do FM and television filters here as well as RF components because we manufacture motorized switches, coaxial patch panels, directional couplers, hybrids. This is for Barbados, or no, I'm sorry, Cayman Islands. I was working on Barbados this morning. 3-4 years ago, we shipped to DMS Broadcasting in the Cayman Islands a system which included an 8-bay Axiom. The Axiom antenna is a Rototiller, but it's a true master FM antenna. It can handle any combination of frequencies over 18 megahertz of the FM band. So we shipped them an 8-bay medium power Axiom. And they put into that a 3-station combiner for 3 different frequencies. Well, now they're adding 5 additional channels to that system. So what will happen is, this is a 935 constant impedance combiner module, and these other 4 modules are constant impedance versions of our new FI 940, which we introduced at the NAB this year. And so this is the broad port, and so the output of that 3-station combiner will be connected here, and then the other 5 channels will be added here, and this will be the new combined output.
Okay.
So
Just adding it on.
we're just adding on 5 channels, and they'll just be added in sequence. And so you've got, because these are constant impedance, you have 2 reflective filters and an input hybrid and an output hybrid. And so in a constant impedance system, you can handle a significant amount of power, and while these are all put together very compactly, so they're all pushed here, with the constant impedance combiner, the modules can be spread anywhere. You don't really care about what the interconnection point is, unlike a T combiner or a manifold combiner, where the coaxial U-links that hook the filters together are actually part of the electrical circuit that does the combining. They most likely won't expand beyond this because they'll be very close to the total power handling of it. And this is for the Cayman Islands, so yeah. It's not like LA where you don't need a 100 kilowatt ERP to cover the Cayman Islands. And then this is just the start of a 5-station system for Harlingen, Texas.
Okay.
So this is just the tanks for the system now. We still have some materials, some parts that are on order and haven't arrived yet. But this will be, these are 4-tank, these will be 4-cavity bandpass filters. So the first 3 banks of these are going to be in a manifold combiner. So there'll be 3 reflective filters, and then there'll be 2 constant impedance filters at the output to add the last 2 channels.
Okay.
And those will all be fed into a 12-bay multiplexed rototiller antenna that's got a special feed system to handle the multiple frequencies.
I'm getting a tour of the ERI factory in Chandler, Indiana with my host, Bill Harland. Once antennas are built, they need to get boxed or crated up and shipped out.
So we're building stuff in buildings all over the campus.
Oh, wow.
And this is where we stage everything to go out. Because, as you can imagine, in many cases, it's like shipping a top-mount TV antenna. A big top-mount TV antenna, shipping it on time is a seldom used skill, because there's always things that come up and slow it down.
Right.
So these are rototillers that are packed and ready to go. This is a new 1190 panel antenna. This is a directional for a big face tower that's staged here to go. This is I think it's 2 bays, 4 around. The base elements for it, and then the power dividers and all those pieces are there. And this is like a 10-bay rototiller.
How much of this How much of your sales are international compared to domestic?
Oh, international is roughly 30% of our total.
Okay.
In the antenna business, it's a little lower than you would find in the transmitter business, and that's because the work in this hemisphere is way higher power than you find outside of the Americas. Europe and big parts of Asia, it's very low power. Their idea in Europe of a big high power transmitter is 10 kilowatts.
Oh, okay, yeah.
So, and here in the U.S., I mean, I was in the FM and TV transmitter business for a long time, and 50% of all the FM transmitters that are shipped are 20 kilowatts or greater. And then this bay, when we have a big panel antenna or a cogwheel, that's where it's assembled here. So these are 2 of our 3 tuning buildings. These are all non-metallic buildings. And we built these 2 for the repack. So this building, which we're using for some FM stuff right now, so this is 81 feet by 240 feet. And it was designed so that we could tune and test up to 4 high-band VHF TV antennas at the same time.
Oh, wow.
So, and what's here is this frame is for tuning. The frame is a model of a 10-foot face tower. And so what that'll do is they'll put the elements for the multi-channel rototiller on it, and we'll actually do the tuning. So we're doing it on a like face of the tower that it will be face mounted on. And then the panel antenna there, that's a 1200 series FM panel, and that's being put together, and they'll put the harness on it and actually tune it in this building, which we can do because there's no metal in the building. It's like all the electrical conduits are PVC, so it's minimized the metal as much as possible, and all the signals go up, so you don't get any reflections from the rebar in the concrete floor. And this tower section here is where we've been doing some axiom development. They haven't pulled it out yet. And they had some extra room, so we used this to stage. This is an 8-station constant impedance FM channel combiner, which is waiting for the building to get done to ship it.
Oh.
This is the building we use for UHF television antennas. So it's 80 feet by 160.
Okay.
And
It's a big section of tower there.
That's a channel 13 high-band VHF TV antenna.
Oh.
And we're storing that for the owner because that's actually a relatively new antenna. We sold them for the repack, and then right after the repack, they moved that channel to a UHF channel. So we sold them a new UHF antenna and took that one down and put the UHF antenna up.
So is that just basically a radome, the orange part? Or
That's
actual antenna element?
No, that's actually a radome, and inside there's a steel outer conductor like you saw.
Okay.
Only this is channel 13, so it's way bigger.
Right.
And so that radome is there. The radome plates keep it centered, and the studs on the top is where the beacon plate goes.
Gotcha.
And at the input, there's an input matching section, and then the input from the transmission line. And then this is the first tuning building we built after we made the Andrew acquisition. And we use this now for the low power TV antennas. This is an elliptically polarized ALP low power TV antenna. These are made up of 4 bay modules, and then they're driven by that power divider. So this is a 16 bay, so there are 4 modules.
Okay.
And then we've got this power divider over here that takes the input signal and splits it 4 ways through 4-phase cables and drives the individual 4 bay modules, which are center fed. And these are the slot covers that'll go on it. So.
Okay. Hi, I'm going to take a moment here and recognize the sponsor of today's video, LinkUp Communications. When your content has to get to your audience, you can count on their content distribution using XDS and other industry-leading platforms. LinkUp has provided distribution solutions with the highest degree of reliability for over 3 decades. If you're wanting more information about their services or just who are they, visit their website at linkupcommunications.com. And now, back to the video. Chandler, Indiana is where I'm at as we continue our tour of the ERI factory. My host for this tour is Bill Harland, who brings me to one of the coolest places I've ever seen.
This is all part of the television antenna design and fabrication. So this is an anechoic chamber. This is, we believe, to be the largest anechoic chamber in the U.S. dedicated to broadcast. And so it's 65 feet long. And so we have a turntable here. The source antenna is at the end here. And so we can put a full-sized element of a single bay of a UHF or high-band VHF TV antenna in here and spin it. And in this anechoic chamber with the cones, you don't get any RF reflections. So we can measure the true pattern as it radiates from the antenna.
Okay.
And so once we have the horizontal plane pattern developed, they'll take this out, they'll move it outside and do the admittance measurements in what we call these Pac-Men, and we'll see that. And once all those measurements are made, it goes into a computer program, which actually lays out the outer conductor to give us the elevation pattern and gain we need and the electrical beam tilt and null fill. And so since we're taking that one element and just stacking it up over and over again, we know what the final pattern is actually going to be. And so the final tuning process is really limited to just doing the elevation pattern. And we measure that using a near-field probe. So that's all done at low power and is just raised up in one of the tuning buildings about 8 feet off the floor. And so they actually take those measured patterns and then they do the input matching section and your antenna's done. But Andrew, and we of course acquired that technology, actually, they're the ones who really started the computer-aided design. Yeah, if we walk down here to the end, the source antenna is on this track that moves in and out so we can change the antennas to work in different frequency bands. And it's on a motor and a positioner so we can spin it and measure the horizontal and vertical polarizations independently. And then this is where rigid line is actually put together. So this is a run of 3 1/8 inch rigid. So it goes into these skids, and these bags that it's encased in are actually impregnated with a corrosion inhibitor. So you'll finish these, and then the interconductors, and these are max line interconductors, so they got the bellows. I'm not holding you up, am I? No, okay. So you have a bellows and fixed interconnector. And so rather than having a watch band spring, the way these work is the antenna or the transmission line heats up and it seats the bullet shoulder in the line section above it. And then this bellows section actually has plus or minus 200% of the travel for the differential temperature expansion between the inner and outer conductor. So there's no movement of metal against metal at all. It's not like having a watch band spring where if you turn the power off, everything shrinks up and moves. Once the bullet's seated, it stays there.
That's cool.
And that's a proprietary design. Andrew developed that back in the 80s. So we've got hundreds of these systems all over the world, so we're very confident of its reliability. And so all of these, they'll load the inner conductors into the outer, and then when this is done, this will have a whole shrink wrap over the top of it. So this thing can go somewhere, sit on a site for months. And if you take the cover off, everything's as shiny as the day it left here.
Nice.
It's something that we do rather than crating, because the reality is most customers don't have an indoor storage space where they can keep this stuff. The reality is it's going to be on the site. We generally don't like to ship things to site where they just sit there, because that way they'll disappear, or they could be damaged. There's nothing like waiting 4 to 6 months for a top-mount TV antenna, and somebody on the tower crew drops a wrench and it goes through the radome, and you're waiting 5 more weeks to get the thing go back to the factory and get fixed. So we more or less like to ship stuff so it shows up when the crew's there to put it up. And since we have our own tower crews, that's often the way we do it. So these are...
I'm in Chandler, Indiana, getting a tour of the ERI factory. My host, Bill Harland, and I moved from the main campus over to the test site just a few miles away. The test site is 50 acres of mostly field and open space. But this is an important part of the factory, where the real-world test can happen before it goes out to the customer's location.
Hey, Robbie. Marcos, this is Robbie Hernandez.
Hey. Nice to meet you. Nice to meet you.
So this is one of 2 test stations. Okay. Yeah, and obviously everything's networked together. So the receive in this case, the antenna under test is transmitting.
Oh, okay.
And so the receive antennas are down there, and basically you've just got a horizontal and vertical dipole in each of those baskets. So you're actually measuring the signal in the far field.
And we're looking at that one right there, right?
Yeah.
Okay.
And then the monopole is the one for the other turntable. We have our own crane out here, and we also have a small machine shop. And unfortunately, you're witnessing some of the tornado damage. And then, of course, we've got all kinds of models that we do, tower sections here, so that we can create models for whatever we need to do.
The 2 tuning houses are a decent distance between each other, so we hop back in the car and drive over to the other one where work is underway testing a customer's antenna.
But what they'll do is they test a 2-bay model. Of course, unless it's a single bay antenna. And in this case, that's a half-wave spaced array, because you can tell because the insulators on the individual arms are opposing each other. And so they actually model the antenna as the structure itself. So, for example, that conduit there is representing a small diameter transmission line.
The one behind it?
The one behind it, yes.
Oh, okay.
And then the directors are there, and they're actually working on developing the pattern shaping so that when they're done, we'll have a 2-bay model. And just like with the TV antennas, then if it's going to be an 8-bay antenna, we just replicate it for the 8 bays.
Okay.
And so as you can see, they're doing the testing, and once they spin it, and get measured results, then they'll go and adjust it. And then, of course, the other option is that we offer is we do this with a computer model. But to be frank, the way you're going to know what you're going to get is a measured pattern.
Actually,
Yeah.
I'm at the factory for antenna maker ERI in Chandler, Indiana. On our way back to the main campus, we take a side trip to downtown Newburgh to see a bit of ERI's history.
This was always, all of these buildings together were the company. So this used to be a restaurant, and that was actually where the antennas were put together, and then the FM antennas, there was a little deck here that they actually tuned the antennas on.
Huh. Wow, from fairly humble beginnings. From the 60s, you said, right?
Yeah, well, it started here in the 60s, but they used to own all the houses around. They'd buy a block of houses, and they'd move people into offices in the houses. And
Back at the main campus, Bill gives me the storied history of the company that started over 80 years ago.
Okay, so the company was founded in 1943.
Oh, a few.
Yeah, so, well, but the FM antenna thing really didn't start till after the war. Where the company came from was during World War II, at Harvard, there was a radio research lab. And most of what they did was, well, that's where chaff was invented. They did radar development. Right. They did air navigation beacons that guided bombers over Germany. And all of that work was done at Harvard. And the problem was, if you're at Harvard, you're in Boston, you're on Boston Harbor. And so the concern was that there were German submarines coming into the harbor, and they were watching all of the research work being done. So one of the people who worked there, Jack Carraway, was from Evansville. And so he suggested that what he'd do is move back to Evansville and start a company, and they would do the field work and research work for the radio research lab, because there was no way the German submarines could get up the Ohio River. And so they came here, and then after the war they did a lot of government research projects. They worked with the Navy and the Department of Aeronautics, which is the predecessor of the FAA, on instrument landing systems and things like that. But they also started doing FM antennas for Collins, for the new FM stations that were coming on the air. And so that went on for some time, and then our CEO, Tom Silliman, his father, Robert Silliman, worked at the Radio Research Lab for Andy Alford. And so after the war, and he was the one who was actually retained by ERI to design the original Collins 37M ring antenna.
Okay.
So after the war was over, Robert Silliman moved to Washington, D.C., started his consulting firm, but he received a call from Collins asking him to come to Indiana and find out why the ERI antennas were no longer working. And so he came here and he discovered that Jack Carraway had died, and his widow and their accountant were trying to run the company. So at that moment, Robert Silliman and two key employees bought the company, and that's where the new ERI came from. That's where the current ERI came from.
Okay.
And they, for years, private labeled antennas for Harris and Collins and Broadcast Electronics. And then in the 80s and 90s, started more or less selling a big part of everything directly. And then in 2003, shortly after I joined the company, we acquired Andrew's broadcast antenna business. Yeah, these are just different. This tracer, a side-mounted tracer antenna. That's back here. This is the 4-bay master antenna that's at WAMU in Washington, D.C. at the American University campus.
Oh, cool.
That antenna actually is the main antenna for WTOP-FM, the #1 billing radio station in America.
Wow.
And this is a T-bar that's under construction during the repack. This is owned by Block Communications over in Louisville.
Okay.
So it's actually in Floyd's Knobs, Indiana. And so they own 2 UHF TV stations over there. One's Fox and the other one's CW now. And so they, we built, that's a 1,000-foot tower with a T-bar on top. So the 2 main antennas are on top, and then there's side mount antennas down about 2/3 down the shaft. And this is Sutro. We did a lot of reinforcement work at Sutro for the repack.
Okay.
And we do a lot of structural analysis. Because we're a tower company, we do a lot of structural analysis. And this is this is here in the factory, but these are a couple shots of the 19-station auxiliary FM combiner for the Empire State Building.
Oh, wow.
So this is actually, we mapped out the floor of the small room it was going into, and we built the mezzanine and everything so that we could put the thing together. And the most important thing was we figured out how we'd put it together in that room.
Yes. Is this the picture of it?
It's just a picture from the other side. Yeah, it's so that's into a 3-bay. These are this is what we call Prudential 2 or Prudential 1, which is a top mount on the John Hancock Center in Boston. And then the antenna there in the lower right left is that's Prudential 2, and that's another 4-bay master. Then the 2 self-supporters are 2,000-foot self-supporters that we built that's on West Tiger Mountain in Seattle.
Wasn't that an incredible tour? That was so cool. I kept asking him questions even off camera because I was just like, okay, so tell me about this. Yeah, that was really neat. And to see the process of these antennas and filters being made and what they go through, where they start off with in parts and then how they end up is really, really neat. So thank you for being along with this. Thank you, ERI, for sponsoring this video and for allowing me to do this site. Thank you, Bill, for your wonderful tour guidance. And yeah, if you want to know more about transmitter sites, this is a video here for you. Or you want to learn about studio sites, this video is here for you. All right, until next time, stay safe, stay healthy, keep learning, because I am, and this was super cool. All right, bye.